Mars. It hangs in our night sky, a tiny rusty red spark. For centuries humanity has gazed towards it, wondering, what secrets does this silent world hold? It's a planet of profound mystery, a celestial neighbor that beckons us with an almost gravitational pull of curiosity. We've dreamt of Martian canals, of ancient civilizations, of life. While some of those early dreams were flights of fancy, the underlying question, the deep yearning to know if we are alone, remains. Mars, more than any other planet in our solar system, seems to offer the tantalizing possibility of an answer. The moniker Red Planet is no mere poetry. It's a stark description. Its surface is covered in iron oxide, common rust, really. This gives Mars its distinctive, fiery hue when viewed from Earth. But beneath that rusty veneer lies a world of incredible geological diversity. It boasts the largest volcano in the solar system, Olympus Mons, and a canyon system, Valles Marineris, that dwarfs our own Grand Canyon. Yet, it's a harsh place. The atmosphere is incredibly thin, less than 1% of Earth's, offering little protection from solar and cosmic radiation. The story of Mars is still unfolding, and its most exciting chapters may be just ahead, waiting to be written by our relentless curiosity. In February 2021, NASA's Perseverance rover executed a flawless landing in Jezero Crater. This crater, a 45-kilometer-wide impact basin, was not chosen by chance. Billions of years ago, it's believed to have held a vast lake, fed by a winding river that formed a distinct delta. Perseverance is a highly sophisticated mobile laboratory, designed to scrutinize the rocks and sediments of this promising locale for biosignatures. The primary mission of Perseverance is astrobiological. It's there to seek out evidence of ancient microbial life. The rover is looking for much subtler clues, specific minerals formed by biological processes, patterns in rock textures, and, crucially, organic molecules. These are the chemical building blocks associated with life as we know it. Within the ancient mudstones of the Jezero Delta, the rover has detected a diverse array of organic molecules. The presence of these molecules in an ancient lakebed, a place where water once pooled, is an incredibly exciting development in our exploration of the Red Planet. This prompts further investigation. The Mars we see today is a cold, dry, and seemingly barren desert. Its thin atmosphere offers little protection from the harsh radiation of space, and liquid water cannot stably exist on its surface for any significant length of time. However, the geological evidence gathered by orbiters and rovers paints a dramatically different picture of Mars's distant past. We see vast, dried-up river channels, intricate valley networks, and enormous outflow plains that speak of catastrophic floods. These features are unmistakable signatures of liquid water flowing across the Martian surface on a grand scale. Jezero Crater, the landing site of the Perseverance rover, is a prime example of this watery past. Satellite imagery clearly shows an ancient river delta fanning out into the crater, a landform identical to those found on Earth where rivers meet lakes or seas. The sediments deposited in such deltas are excellent at preserving organic matter and potential signs of life. This is why Jezero was chosen. The implications of this abundant ancient water are profound. Finding organic molecules on Mars is a monumental step, but it's crucial to interpret what this discovery truly means. These carbon-based compounds are intimately linked with life on Earth. They form the very fabric of living organisms, from the simplest bacteria to complex animals. DNA, proteins, carbohydrates, and lipids are all organic molecules. So, when we find them on another planet, particularly in an environment that once held water, the question of life naturally comes to the forefront. However, organic molecules are not, in themselves, proof of life. There are numerous non-biological processes that can create complex carbon chemistry. The excitement surrounding the Perseverance discoveries in Jezero Crater stems from the context. These organic molecules are being found in sedimentary rocks laid down in water in an ancient lake delta. This is precisely the kind of environment where, if life did exist on Mars, its remnants might be concentrated and preserved. The search for organic molecules on Mars didn't begin with Perseverance. NASA's Curiosity rover, which has been exploring Gale Crater since 2012, also found evidence of simpler organic compounds. These included thiophanes, benzene, toluene, and small carbon chains. These discoveries were significant, proving that organic molecules could indeed be preserved in the Martian environment. Perseverance, with its more sophisticated suite of instruments like Sherlock, is designed to detect a wider range of organic molecules and to map their distribution with greater precision. The initial reports confirm the presence of diverse carbon-based compounds within Jezero's deltaic sediments. These are not just fleeting traces but are embedded within the rock record, suggesting they have been there for a very long time. The fact that these molecules are found preserved within rocks, particularly fine-grained sedimentary rocks like mudstone, suggests that they were buried and protected from harsh surface conditions. The context in which these molecules are found is paramount. Perseverance is not just finding molecules, it's mapping their geological setting, providing crucial information that will help scientists unravel their true origin story. While our robotic explorers like Perseverance are incredibly capable, there are inherent limitations to the analyses they can conduct remotely. To truly unlock the secrets held within Martian rocks, we need to bring samples back to our planet for detailed study. This is the ambitious goal of the Mars Sample Return MSR campaign, a multi-mission endeavor being planned jointly by NASA and the European Space Agency, ESA. Perseverance is the first leg of this relay, carefully selecting and caching scientifically compelling rock and soil samples in special tubes. These samples are being left in designated depots on the Martian surface. The plan is for a subsequent lander to retrieve these cached tubes, using a small fetch rover, and then launch them into Mars orbit aboard a small rocket, the Mars Ascent Vehicle. Once in Mars orbit, a capture, containment and return system provided by ESA would rendezvous with the orbiting sample container, secure it, and then begin the journey back to Earth. The samples would re-enter Earth's atmosphere in a highly robust and protected entry vehicle. This complex series of missions represents an enormous engineering and logistical challenge, pushing the boundaries of robotic space exploration further than ever before. Upon their arrival, these precious Martian samples would be curated in a specially designed sample receiving facility. The discovery of complex organic molecules, and the tantalizing prospect of confirming ancient life on Mars through sample return, carries implications far beyond the realm of planetary science. If we were to find definitive evidence that life arose independently on another world, it would be one of the most profound discoveries in human history. It would fundamentally change our perception of our place in the cosmos. It would suggest that life is not a unique fluke confined to Earth, but perhaps a common cosmic phenomenon. This ongoing exploration of Mars is also paving the way for an even bolder dream human footsteps on the Red Planet. The challenges are immense: the long journey, the harsh radiation environment, the physiological and psychological toll on astronauts, and the need to create sustainable habitats. Yet, the drive to explore, to experience, to be present on another world is a powerful human aspiration. Each rover mission teaches us more about the Martian environment, its resources and its hazards, providing crucial knowledge for planning future human expeditions. Mars could one day serve as a proving ground, a stepping stone for humanity's expansion into the wider solar system. The search for life on Mars, the meticulous collection of samples, and the dream of human missions are all part of a grander human narrative. Please like, share, and subscribe for more content like this.